All right, let's talk about pollution, but probably not in the way you're used to thinking about it. We're not just talking about the obvious stuff, the plastic bags you see or the big plumes of smoke. Today we're going to be decoding the unseen, all those invisible forces in our air, our water, and even in the sounds all around us.
I mean, think about that for a second. It's a pretty wild thought, isn't it? We spend so much time worrying about the dangers we can see, but what if the real heavy hitters are the ones we're breathing in, drinking, and hearing every single day without even realizing the damage they're doing?
Because at its core, that's all pollution really is, something harmful that's ended up where it shouldn't be. And as we're about to find out, some of the most widespread pollutants are the ones that completely fly under our radar. We can't see them, we can't taste them, and we can't smell them.
So let's dive right in, and let's start with the very air we're breathing. It's so easy to just think of it as, well, air. But honestly, in a lot of places, it's much more like a complex chemical cocktail. And some of the ingredients in that cocktail are pretty shocking.
So how does this cocktail get made? Well, you basically have two types of ingredients. First, you've got your primary pollutants. Think of these as the raw stuff, the ingredients that are dumped straight into the air from a car's tailpipe or a factory. But then, you've got secondary pollutants. And these are what happens when those raw ingredients get mixed together and kind of cooked by sunlight and other chemicals that are already up there. They create brand new substances, and a lot of the time, they're even more dangerous.
And this right here shows how different recipes can create totally different problems. You have the famous London smog, right? People call it winter smog. That was basically smoke and sulfur dioxide mixing with cold, wet fog. But on the flip side, you have Los Angeles smog, or summer smog. That's a photochemical reaction. It's what you get when intense sunlight bakes all the nitrogen oxides and hydrocarbons from traffic. Two completely different kinds of pollution, just from a different set of ingredients and conditions.
Now, in this whole chemical soup that we call air pollution, there's one particular ingredient that scientists are seriously concerned about. It's called particulate matter, specifically the really, really tiny stuff.
This is the one to remember, PM 2.5. We're talking about microscopic particles from things like car exhaust and burning fuels. They are so unbelievably fine that when you breathe them in, they don't just get stuck in your lungs. Oh no, they can pass right through the lung tissue and get into your bloodstream, traveling all over your body. It's a truly invisible threat, but it has very, very visible health consequences.
And speaking of invisible threats, let's talk for a second about carbon monoxide. Here's what makes it so incredibly sneaky and dangerous. Your blood carries oxygen around your body using a protein called hemoglobin. But hemoglobin is actually 200 times more attracted to a carbon monoxide molecule than it is to an oxygen molecule. So if both are around, your blood cells will literally grab onto the carbon monoxide and just ignore the oxygen, basically starving your body of what it needs to live.
Okay, let's move on to our next unseen threat. And this time, it's hiding in our water. And what's so fascinating here is how the problem can start with something that seems totally harmless, even good, nutrients. But as you'll see, too much of a good thing can lead to this slow, silent suffocation.
To wrap our heads around this, we need to understand a key measurement, biochemical oxygen demand, or just BOD. Put simply, BOD tells us how much oxygen the bacteria in the water need to break down organic waste. So if there's a ton of waste, the bacteria go into a feeding frenzy and they use up a ton of oxygen. A high BOD level is a huge red flag. It means the water is literally being starved of oxygen.
And that brings us to this tragic chain reaction called eutrophication. It starts when way too many nutrients, like from farm fertilizers, wash into a lake or a river. This causes a massive, explosive growth of algae. You've probably heard of an algal bloom. But then, all that algae dies, and the bacteria that decompose the dead algae, they go into overdrive, sucking up every last bit of dissolved oxygen in the water. This is what creates dead zones, where fish and everything else that lives in the water literally suffocate.
And beyond just oxygen loss, you have specific chemical contaminants with these direct, devastating results. I mean, just look at this. Mercury in the water leads to Minamata disease, a horrible neurological syndrome. Cadmium contamination causes the excruciatingly painful itai-itai disease, which softens your bones. Nitrates in drinking water can cause blue baby syndrome in infants. The point is, these are poisons you can't see, but their effects are absolutely terrifying.
All right, on to our last category of unseen pollution, and that's noise. This one is tricky because, yeah, we can hear it, but our brains don't really process its true power correctly.
There's a sort of loudness illusion happening, and it's all because of how we measure it. So we measure noise using the decibel scale, right? dB. But here is the critical thing to understand. It's not linear. It's not like a ruler, where 2 is twice as much as 1. It's logarithmic. What that means is, for every 10 decibel increase, the actual sound intensity, the raw energy of the sound, goes up by a factor of 10.
Let's look at some real-world numbers to see what I mean. In India, for example, the daytime noise limit in a residential area is 55 decibels. In a commercial area, it goes up to 65, and in an industrial zone, it's 75. Now, just looking at those numbers, they don't seem that far apart, do they? 55, 65, 75.
But that's the illusion. Remember, it's a logarithmic scale. So that 20 decibel jump from a residential street to an industrial zone isn't just a little bit louder. The jump from 55 to 65 is 10 times the intensity, and the jump from 65 to 75 is another 10 times. So we're talking about a 100-fold increase in the raw sound energy hitting your ears. That is a huge, huge difference.
So there you have it. We've decoded the chemical cocktail in our air, the silent suffocation happening in our water, and the loudness illusion of noise. Really, the whole point here was to give you a kind of toolkit, a new set of lenses for seeing these invisible forces all around us.
And here it is. Consider this your pollution decoder ring. These are the key metrics that make the invisible visible. So from now on, when you hear about air quality, you'll know to look for that PM 2.5 value. When you read about a local river's health, you can ask about its BOD level. And when you think about how loud something is, you'll remember the hidden power behind that little decibel number.
You know, these tools don't just help us understand pollution. They give us the power to ask better questions and to see our own world with so much more clarity. So I'll leave you with this one last question. Now that you can see the invisible, what are you going to start noticing?